Hello. Hello. Can you hear me? Is the Magnaya? Hello. Am I audible? Hello. Okay. Thank you. So, shall we get started or how is it? Fatima, I cannot hear you, Fatima. Okay.
Hello, hello.
Hello.
Hello, am I audible now?
Yes, I can hear you.
Okay, so we'll wait for a few minutes more and
Sure.
then we'll start.
Okay, cool.
Okay, so I think we can start now. I'd like to welcome everyone with a very warm good evening. I'm Fatima Hirani, and I work as a communication designer at the RedX V School Lab at Wellington Institute of Management, Mumbai. With us, we have here our lead research engineer at our innovation lab, Professor Subhav Devlekar, and Sushant. He works as an electronics engineer here in the lab. We also have with us here Mr. Sagar Deshmukh from our IIC team. To give a little brief about our lab, at our edX lab, we build citizen-centric innovative solutions. And to keep the spirit of, all our tech enthusiasts alive, we've been hosting this session called RedX Cafe, where we host various sessions on different emerging technologies. And for today's session, we have here with us Mr. Tamagna Basu. He's going to be speaking on different innovations in cybersecurity analytics. To give a little background on Mr. Tamagna, he is the co-founder and CEO at Data Secure. It is a company which has worked and managed cybersecurity practices and global delivery in large companies like PwC, eBay, PayPal, Walmart Labs, ThoughtWorks, etc., among others. He is also CEO and co-founder at NeoIte. At NeoIte, they look after the cybersecurity needs of various organizations and help them build secure products and protect their data at the same time. Mr. Tamagna also mentors at multiple organizations like Atal Community Innovation Incubation Center, Niti Aayog, Seven Prosper, Great Learning, and SANS Institute. We are extremely delighted to have him here as a speaker today, and we can't wait to learn all about cybersecurity from him. Over to you, Mr. Tamagna.
Hi, thank you so much, Fatima, for the introduction. Yeah, I think thank you for the invitation. So I'm glad to be part of this initiative. Yeah, I think without further delay, let's get started. So I'm super excited, and it's always my pleasure to interact with students community and like-minded people who love to learn about technology and innovations, right? So I'm just gonna share my screen, and I'll so this is me. Okay, so I think just to save bandwidth, I'll switch off the video for now, and I'll share my screen so that you can see the presentation, right? Let me know once you're able to see the presentation. And I'm switching off.
Yes, we can see
Yes,
your
is my
screen now.
screen visible?
Yes.
Great. Okay, I'm just putting it on the slide mode. Can you see it as a full screen slide?
Yes, sir.
Great. Okay. So yeah, I think yeah, there's quite a lot of things we'll talk. I think yeah, thank you, Fatima, for the warm introduction. A quick correction. In NeoEd, I was a CTO, not CEO, and yeah, and in my second, that's my first company, and my second company, Data Sequel, this is where I play the role of CEO. But however, I am a techie. I've been techie even today also. Obviously, I work with the developers. Write code. Pair with them. Like we do pairing, code pairing. I don't know if you are familiar with that. That two developers will sit together, write code together on the same screen. So those are the few things do. So coding, development, tech is always close to my heart. And yeah, I think one of the way I keep my learning motivation on is by teaching, right? So the way I see it, we say teaching is the best way of learning. So that's why I say, I'm glad, I think more than you, I'm super excited to be part of this webinar. Great. So let's move on. So basically, what I'm going to talk about is, and just to share a brief background about why this talk, what is the relevance of this talk, and about in my total journey. So as I say, as a techie, I kind of looked into various problem statement and see that how can that be solved better, right, or differently. So I am obviously a cybersecurity expert, but when you talk about security, it's very generic, right? Security has different area, different segments. You talk about server security, network security, product security. You talk about also there's a two aspects, offensive and defensive, right? We talk about hacking, right? We talk about exploitations, and people actually there are people are actually trying to exploit things out of the system. So there's offensive, and there are a set of people who actually do defensive part of it, who actually look into the how to protect the system, right? So there is offensive and defensive, two different layers, and each aspect also had different kind of segment in terms of network layer, server layer, infrastructure layer, cloud security, and all these things. So there are a lot of subdomains are there, and when we actually come into the field, first of all, we as a security expert, we learn holistic overview, like in general and their spectrum of security, but eventually we deep dive into a specialization, and that's how you get specialized person who are actually experts in, probably, as I said, cloud security or mobile security, like that. Now so far, obviously, in the industry, whatever I've seen, like more than 2 decades is, obviously there is a huge paradigm shift happened. Like initially it was more like a lot of manual effort is happening. People actually do on a day-to-day basis, on a manually hands-on. But I think thanks to the technology, thanks to AI and automation, right, there are a lot of things people actually now could do better and faster. um, because there is a huge scope of automation, there's a huge scope of analytics, there's a huge scope of learning from the experience, right? AI is nothing but, obviously, if we talk about supervised and unsupervised, it's just an algorithm at the end of the day, and you actually get trained, and it actually you help that algorithm to understand how to solve a problem in a better manner, right? So there's huge, and that opens up a different category of problem statements, because there are a lot of, and that's why it's a security is a continuously evolved segment. whatever is secured probably 2 years back, it's no longer secured today, right? And I think most relevant example I could give is encryptions, right? That's how probably if you're familiar with encryption, the algorithms keeps changing, from more complex algorithms, right? So earlier, whatever was difficult to decrypt or difficult to crack as an encryption is no longer valid. Today, there is a lot of encryptions can be broken thanks to a lot of computes, a lot of GPUs, and especially quantums now, right? With the quantums, things can be done very easily. So now that opens up a new subject called quantum safe computing. But anyway, the point I'm trying to make is, now we see in industry there is a perception that AI is different, and obviously security is different, but there is a very good synergy between it, because security is a domain and AI is like a way of solving certain things, and which you can apply to a specific domain, right? Which is security. And now when you talk about AI can be used for both offensive purpose and defensive. As I said, security you can use different tool. Like it's like think of it like a gun, right? You can use a gun to obviously attack somebody, or a weapon in general, or you can use it to defend yourself, right? So like that. So I'm going to talk about these two briefly, these two aspects. How in recent past different kind of new trend in terms of AI, which is kind of crept into the cybersecurity space. And obviously I cannot cover everything, but give you just a gist, just an like a spark in terms of what are the different innovative ways people are trying to solve problems which otherwise people wouldn't have done, or we felt that is very futuristic, we only saw it in the movies and stuff like that, right? But that's pretty real today. So mainly two tailored adversarial AI and behavioral AI. So adversarial AI is nothing but where you use AI to kind of to exploit or to attack or to actually do something which is not not good. And obviously there's a defensive aspect. There are a lot of other areas are there, but I think one area which I have worked on in my personally is the behavioral AI, and that's why I'm going to touch upon and talk about what exactly that means and how that works, right? If you have any questions, you feel free to put it on the chat box. What I'm going to do is probably, we'll complete this, and at the end of it, we can look into Q&A, or probably Fatima, someone from your side, can look through the questions, and we can have a Q&A at the end of it, right? So typically, most common application of AI, if you ask, we in our space in cybersecurity, people do is like log analysis, malware analysis, network traffic analysis, or in general, this entire subject is called UEBA, user entity and behavioral analysis. What essentially that means, this is nothing but anomaly detection, right? So at the end of the day, the idea is I am there are a lot of users are using my network, a lot of users are using my servers, there are a lot of employees are actually connected to my network. Is there any anomaly? Is there any malicious? Is there any anything suspicious is happening in my network? I need to identify, and if it is happening, how soon I can actually contain that and eventually mitigate that, right? There are three layers. So how do you do it? As I said, and obviously you have to continuously monitor. So monitoring and the anomaly detection is very common, and that's why majorly the AI is being used in the cybersecurity space. Uh, However, what I'm going to talk about, that not this common part, because this part is very common. There are a lot of tools, a lot of papers are there, but I'm going to talk about what are the next futuristic stuff which is happening in the space, right? But essentially, AI, in short, if you ask me, the majority of the applicability of AI, ML into the cybersecurity space is on analytics, on monitoring, on anomaly detection, on outlier detection, to be precise, right? Those are the things people use for. Now, what data, what layer you're playing that, based on that, you have different kind of tools. Like if you're doing on the network layer, that's why nowadays there is a context or firewalls and those kind of things are coming. And if you're doing under the product layer, probably there is a software, kind of develop SDN layer. There's a lot of smart software based, solutions are coming. So different layer has different kind of tools, and depending on the data, tools coming in. But as I said, now it becomes so smart. Obviously, people are started using it for offensive kind of use cases as well, right? So there are few examples I can just touch upon. So I believe you guys know what is Captcha, right? So Captcha is uh, way of preventing that, an automation attack to your website, right? When so Captcha is a way of actually identifying that, when I'm actually, using an app, is it a human? Is it actually a person who is doing, or is it an automated script which is trying to do it? So most frequently, Captcha gets used where they get used in, let's say, the login pages, registration page, payment page. These are the various page which is sensitive, where that actually, let's say for example, if you have a login page, and what if I have 10,000 or 100,000 or 1 million password as a dictionary? I write a small script which will automatically keep sending one by one all the password and see that, can I log in? Can I log in? Can I log in? Right? So to prevent, this is called a brute force attack. Now, prevent the brute force attack, people actually put a captcha, because captcha actually has a way any automation script shouldn't be able to identify and break the captcha. And the captcha has different versions. It started initially with the number based, then it become a reCAPTCHA, reCAPTCHA V2, which is basically now you get a checkbox, or I don't know if you see this kind of images where it will ask you to click on all the pictures which has, let's say, traffic lights, or click the pictures which has some bus or train, something like that, right? So those are the ways actually to identify when you're clicking it, that this is actually a person, a human is clicking on the picture. Hence, they actually let you use that platform. Now, the idea fundamentals of capture was, as I said, to prevent automated attack. Now, it's quite possible today is actually people have seen it, and we've seen some of the research, and that's what I was going to show is you can use AI to train in such a way that it will behave like a captcha, behave like a human, and actually, or maybe it can actually bypass the actual validation, and it will be able to access the site without even any human intervention, right? Few other use cases, obviously people are trying to guess passwords. A lot of AI attacks we're seeing where the AI engine is actually try to guess password of users, and that is something people are using it for. And there are a few other detect vulnerability and automated attacks are there, right? So yeah, I think this is a very simple captcha. And people who don't know what is captcha, obviously, I just wanted to just recap how does it look, and it's pretty familiar, I think, and I believe you get an image like that, and you are supposed to type the characters there which is there in the image, right? And then that's what manually you type, because the assumption here is, since this is an image, a person will look into it, and then only a person can actually figure out this is what the letters inside or alphabets inside, um, and then they will type. Now, that's exactly what I'm saying, that now people, so we have created a kind of a model which actually has multiple aspects, computer vision, which will look into this image, and then obviously it will learn from the image that how the different letter looks like, and then eventually, look, given an image, it can predict that what exactly is the alphabets or letters or numbers are there inside, right? So this is one of the examples. So now, the problem is this looks very simple, but the problem where comes is, obviously, people who have created captcha, they try to make it as difficult as possible. So what they exactly did, they try to do something like, the numbers will be in different coordinates, like, it's something will be towards the bottom, sometime it will be on the up. So it's like you're not in the same line. They will tilt the letters or alphabets or numbers. Like, it is not always going to be like vertical. It will be like 45-degree left, 45-degree right, like that. Sometimes you see, some smarter ones, people do a strike through also, right? There will be a lines in between, like, it's like a strike through. So like that, different kind of, different samples, the image gets generated with. And the idea of this is basically, if you simply put a computer vision, that fails here, right? And that will fail here, because if you only put a computer vision, they might only understand that, A looks like this, which is like a two like triangle kind of thing line, and then obviously it should be straight like that. But the moment you tilt the A a little bit like this, probably the computer vision will fail, right? So that is where the challenges come, and obviously the initial attacks is failing. But however, now there's a possibility that I can do a supervised learning here. So what if, think of it like, is there a way I can, if I can extract out this A, like all the tilted versions of this, and club them together and train a AI model, telling that, what, no matter whether it's little tilted left, right, or this thing, as long as this is the kind of edges or this is the kind of pattern you see, you should predict that as an A, right? So that is essentially what CNN is about, right? People who are into AI, you probably will see that CNN works in the similar kind of similar kind of function, right? Convolution neural network, because that actually do this kind of recognition, and that actually solves this disposition problem, right? Whether the characters or the image is actually a little bit left, right, or up and down kind of thing. The position, because this works with the vector, right? And it actually creates various kind of. I'm not getting into too much detail, but creates a kind of a filter, and using the filter it can identify that this is 2 or this is M, this is 8, like that. So essentially what we can do is we can actually take an image like this, and we can extract out all possible combinations of, let's say, the on specific letter, and then we can train a CNN, which will then understand that, okay, and it will have different, depending on how many layers we are creating in between. It will be more accurate, and it will know that, okay, this is the kind of shape. As long as I see the shape, it will be W, right? Now the question comes, obviously, how do I get this small shapes, right? So that is why even automation comes, because if you see this specific example of Captcha, it actually takes almost similar space into the entire image. So we can actually split this image in 1/4, like, let's say if this is the length, which is like 4 units, I can actually split it in 1 unit each, length and then obviously height. And I can assume that that area will contain one specific alphabet or letter, right? So that's how we can actually split an image, and we can get these different shapes, and then we can train a model. And once this training is done, we will be able to get a model which will be able to predict this specific letter with quite high accuracy. Now if you repeat that with all the 26 alphabets, and obviously 0 to 10 numbers, eventually we'll get a model which will can predict any combination of this alphabets and numbers, right? Now, however, in Captcha, generally people don't use 0 and O, because that's looks similar. So obviously that leads to failure. Similarly, 1 and L, no, generally use. So this is how this specific thing works. So think of the, like, there is CNN, convolution neural network, and that has certain obviously properties which supposed to be used for good purpose. But now, by definition, it can handle the complexity which a Captcha is introducing to prevent an automation attack, and I can use this to break it. Now, what I've just given an example that's actually happened, and this is a example of a plugin called Really Simple Captcha. It's a WordPress plugin. So, and there's a blog also, so how to break a Captcha in 15 minutes. So if you actually see, this is pretty old, 2017, this guy has wrote this blog, and the source code and everything is available. So with this code, and if you can use this model, if there is any website which is using this specific Captcha plugin of WordPress, you can break it with almost 99% accuracy. Now, this is a simple Captcha. You might ask it, today who use so many, so such a simple Captcha, because today a lot of this reCAPTCHA V2, all the smart captures came, right? Then you're talking about like pretty obsolete data point. But then if you go still even today and go to WordPress plugin website and search for this, you will see that 1 million plus active installations there. So what does that mean? That means that although this is an obsolete technology, people are still using it, and unfortunately they will be vulnerable to this specific attack which I just explained. And this attack, the entire source code is an open source project, is available in the internet. So now if you want to be a hacker, and if you actually don't want to attack, so if you find, you have to find websites which has this Captcha, and then obviously you can just get this code and just write a script which will go fetch that Captcha image from the website, run it through your model, and you just put that number there, and you're done. Then your Captcha is bypassed, right? So this is it sounds very simple, but obviously, to come to this stage, obviously, there was a lot of effort and a lot of this thing. So this is one of the example of the website we I found in the internet where they were still using on their comment section a captcha. This is captcha. So essentially, the idea here is I don't want automation script to put random comments and keep sending and eventually fill my database, right? I want actual people to come and do the what is that called, do the commenting. So this can be easily bypassed, and you can actually do a denial of service attack by creating an automation script with this kind of convolution neural network. This is another research on that, breaking captcha in almost 0.05 seconds. It's pretty fast. This is the year after there was another research, and Roberto has taken it to the next level, where they have actually also went to a little more complex captures where there's a background, textured background, when there was a little tilted or disoriented, distorted letters, all this such and that. But this is still done, and in this research paper has been published that they have tried at that point of time with a lot of well-known companies, and I don't know if you know of eBay, Amazon, Wikipedia. They were the captures, and the kind of success rate you can see with eBay, almost 60% success rate is got actually. With Baidu, almost 50%. So like that, it is pretty, and then the accuracy also is there. So they got some kind of sorry, my bad. They got 90% accuracy, and this is their approach, and this is like the reference. So you got like fairly 80 to 90% accuracy across all well-known website and their capture used by those specific websites. So essentially, so captures, this specific image-based captures is no longer solving the purpose, assuming that if you know enough to use AI to exploit captcha, right? So that's the point of it. So these are the things called adversarial attacks or adversarial AI. So basically, what you try to do is not the adversarial AI, like there's a specific meaning of that in the AI world, but in our security world, this is called attacks, right? Offensive attacks or adversarial attacks, right? So moving on, this is so there is something called GAN, generative adversarial network, and so there is obviously another it's a deep learning approach, and somebody has created actually a, a customized version of GAN called pass GAN, which essentially is trained with a lot of say sample passwords and data. And essentially the idea of this is this project can help you to guess passwords for an user. Now, how does it work? So how, what problem it's solving? So today, let's say if I'm an attacker or hacker, right? Let's say, so what hackers do, they obviously they hack into different things, and one of the first step or first one more major category of hacking is obviously authentication bypass, or basically how can I hack into your account, right? So this is called identity fraud or account takeover or authentication bypass. These are the various terms we use. Now, essentially, what does that mean is, let's say I want to hack into your Facebook account. So essentially, what I need to do is I have to predict your, and I have, let's say, your email address. I have to predict your Facebook, which password you have used for that specific email on Facebook, right? Now, the age-old way or conventional way people have been doing is, we call as dictionary, right? We carry with us, let's say, a millions and billions of passwords, sample passwords together. Let's say we call them, we're talking about terabytes of data, right? Not even GBs, the TVs of password dictionary, which is like 1 billion passwords, which is collected all over internet, with from the dark nets and other, other hack database and all this thing. And we assume that, okay, let's try a brute force attack, which is trial and error. One by one, we'll send all this password for this username, and we'll see that if we get lucky, we will obviously get the access. Now, obviously, the probability is very low because it depends on how big is your dictionary, and obviously how tech savvy the user is, whether the user has put the right kind of password or complex passwords or not, right? Now, this, if I now think of this, why this research was relevant to us, because if I create a model, an AI algorithm, which can generate password at runtime, which is relevant, which is actually to the user, I don't have to, first of all, I don't need to carry this terabytes of data and gigabytes of GBs or billions of password dictionary, right? Because now I have a model which can generate password on the fly. So I don't need to do it. Now, so that is one part, and second part is obviously this makes my attack much faster, because the kind of the notion of this project is, can I generate a password which is more relevant to the user, and which is a probability of having that password for that user is high. Now, how do we feed in this probability, right? So it's nothing but different kind of assumptions, a different kind of parameters we actually generally see in the as a pattern. For example, how people keep passwords for their accounts, right? Probably they their loved ones put as their name, and followed by probably a special character, or probably followed by numbers, like that. That could be one pattern. Sometimes they see each user has different okay, I'll come to that a little bit, but each user has certain patterns. And so what if we can get a kind of little bit of, we call it social engineering. We can get an analysis of the person, individuals, and see what kind of close persons that person is connected with, or around. And let's say try with a kind of possible password combination of those people's name with some numbers, with some special character. So this is at the end of the trial and error, but the question is how efficiently you can guess it. And this kind of this is called frequency analysis. So this kind of pattern generally we analyze on a dictionary. Whenever, let's say, there's a data breach happened, or let's say LinkedIn data got hacked and all password got public. So people do analysis and see that, okay, how many people have actually created a password with a human name into it. How many people have created a password with probably, let's say, only letters, only alphabets, like 1 2 3 4 5 6 7, only numbers, sorry, like that, right? So with that frequency, those numbers, you create a probabilistic, kind of, heuristic or theory, and then you try to, feed that into the algorithm to see that, these are the various kind of theory, or various kind of parameter you should consider and generate a password. So this is again an open source project, but the idea of this project is actually, let's create an AI which can help you to crack someone's password faster, right? So these are the all of offensive attacks are happening. So I have actually last year I've done a course. So I've conducted a workshop on this in the US, where we actually help people to understand, how to do this kind of attack. And not only this, we have also seen something called like adversarial attacks. For example, facial recognition bypass. Right, we are able to, let's say, um, put someone else's face to our facial recognition algorithm and convince the algorithm that this is not person A but person B, right? So these are all things are pretty possible. And it all leads to, if you're familiar with AI algorithms, obviously it's basically an experiment you do with gradient descent, and try to make that two samples as close as possible without seeing a visible difference, but actually the way it translates to the model, it looks like it goes to the same kind of output, right? So coming back to this, these are some questions I generally ask on a in-person session, that how many of you keep the same password for all your accounts? Since this webinar, obviously, I won't be able to get the replies, but you can think of for yourself. But I can tell you the statistics: 55%, almost 60% users, they keep same password for most, if not all, websites. So this is another theory. So on an average, every human being manages 10 to 15 accounts on a daily basis, or at least own 10 to 15 accounts, which they have to log in at least once a month. Now, it's very difficult in today's world to remember all this, if you put 15 different passwords into it. So essentially, yeah, so what people try to do, they keep same password for all their accounts, right? Now, what does that mean? For example, that means, for example, if your Facebook and LinkedIn passwords are same, and let's say, somehow if your LinkedIn data got breached, and I have that account, I have your email address, and I have that password which you have used for LinkedIn, what I'll be doing it, I'll be going to Facebook and feed in the same username and password, and see that, can I log in there, right? And you won't believe, so there is a pretty decent amount of success ratio, and which is essentially lead to this number. 55% of the cases, probably I will probably be able to even log into your other account, just because of the fact that you want to simplify your life by keeping same password in all of your accounts. right? Now what essentially that means, this actually also leads to the same thing, that it's a repeat, it's a sometimes hacking is not a complex thing, it's actually it's a repeated attack, right? It's just a simplicity, which which the users bring to their life, and that cause this kind of problem. These are the interesting statistics, which is basically the top 20 common password across the world, which people actually have used. So this is basically, again, kind of research has been done by on a breach data. So what happened is, so what as security professional, a lot of us do, we whenever we see a data breach, we actually try to go and we do a frequency analysis, right? So let's say I got like 1 billion passwords, which is breached, and a lot of time hackers, when they breach the data, they make it public, they make it torrents, they make it available in dark web and all this thing. They sell it also sometimes, credit card details and all this. So then there is a frequency analysis happen, that what is the common. So this is a research done on, I think, some 1 billion passwords of different people across the globe. I don't know the exact, but it's, I guess in that volume, that kind of volume, and did a frequency analysis to see what are the top 20 passwords. And although the number 4.1% looks very small, but if you think of a scale of, let's say, billions of users, obviously, this is a pretty big number. So people keep simple passwords, and that actually leads to, obviously, a lot of data breaches, right? So essentially, not always it is about the technology, but sometimes it's about this kind of simple human analysis you do, and then you see that, okay, how to make that vulnerable. So very interesting use case I just came across recently, and where some people are actually hacking into other people's Gmail account, to be precise, that mobiles, Android mobiles account. How they do it, basically, what they do is, especially in the rural area, or probably tier 2, tier 3 cities, or probably some people who are not tech savvy, when they buy a smartphone, typically the shopkeeper or shop owner, they install the mobile, or they set up the Android phones for them, right? And when they do what they do, they actually use the username as mobile number, and password is also as their mobile number. Now, what does that mean? Today, if I get, let's say, some 100,000 mobile numbers across different network, Airtel, Vodafone, and these things, all I have to do is I have to go to Gmail, and I have to one by one put the same number as username, same mobile number as password, and see how many times I can get logged in. The moment I get logged in, I will go and I'll simply change the password and put some random password of mine. The moment I do it, immediately that phone will get logged, because that account says that, the password has changed. You please enter a new password. Until you enter a new password, you won't be able to, access your emails, or the phone will not be functioning properly. You will not be able to log into Play Stores, update your applications. A lot of things can happen, right? So this is at the time also, this makes us very scary at times, because the problem is not security. The problem is, you are your data is owned or managed by the other set of people who don't know how to protect data. So they are not making themselves vulnerable. They are also, because they're responsible for other people, their data is also vulnerable, right? So that kind of, that's why I'm saying this password based, any kind of login is very much scary, and very much kind of, vulnerable. And the way to solve it is, obviously, you give a complex password. Now the moment you put a complex password, that brings to the second question, that if you are not frequently using that account, definitely you will forget the password, right? So obviously, to solve problem one, you actually, bring problem two into your life, which is that, you keep forgetting password of your data, and obviously you have to go to forget passwords. Now don't worry, you're not the only person, because when we did a analysis, we see that, obviously almost 70% people actually forget their password, or their account get locked, because they forget and they try multiple times. And also people leave those accounts, they don't come back, because they when they try to recover, they feel frustrated, because it asks for some recovery questions, secret questions, this and that, and they say, you know what, no, I don't want to do all this nonsense, and I don't need this account. So yeah, this is a pretty big number also, and these two are quite related, because problem one leads to problem two, and if you want to solve problem two, it actually bring problem one to your life, right? How many of you watch? Let me rephrase these questions. The third question obviously is about share password sharing, right? And Netflix obviously in India was very popular. This space, people do share. They used to share. I don't know how is it right now, but Netflix password with your friends, especially in colleges. Obviously, this is pretty common, right? So password sharing is another big problem. Now, all this kind of leads to obviously different problem, and that's why the passgan and this kind of different smart attacks is possible. Now, how do we protect ourselves? So, the way we can protect is obviously, can we do something better than that? Can we do something which is different than passwords, right? Which is, and that's why the next set of very interesting kind of research has been happening in the security space, where we're extensively trying to apply AI, and that's called obviously behavioral biometrics. So what essentially we do is we try to say that, look, biometrics, facial recognition, fingerprint, voice recognition, but there are something more also we could do, because those things are there, but they're not solving a problem, or they're not very easy to adopt. There's a lot of friction. We don't find a solution which I can use like that. So what are the next set of thing which we could do, which is really, really, really cool and really interesting and can solve the problem in a different way? So these are various solved problem, and we'll go into it one by one, and we'll look into that also. What is this? So first one is called past thoughts. So past thoughts is basically a concept where uh, your brain pattern could be your password. So the concept here is very simple. It's like, um, so you think of something. So there is something called BCI, brain computing interface. So this is the kind of obviously there are different look, shape, and form you can find in the industry, but the idea is, there's different devices nowadays come, like looks like headphone. You can wear it, and the moment you wear it, it actually can capture various signals, like wave signals from your brain, alpha signal and stuff like that. And you can actually capture that, and put it into obviously plot it into a graph, or study those patterns and all this thing. Now, what essentially they are saying that, think of a situation where uh, your password will not be what you remember, in terms of, it's not a word or sentence, but as a memory. Let's say, what if I can create an algorithm, or kind of a system where, if you whenever you want to log into a system, you have to think of a memory of, which could be a good memory, bad memory, or something, a good experience. And when you're thinking about that memory, the kind of expressions, or the kind of various signals it emits from your brain, that can be captured by this. And as long as this pattern matches, you can actually log in. So this is called obviously your thought process. Your thinking is your password. That's why it's called past thoughts, right? So there's an experiment done where people actually asked to do breathing, thinking of some memories, singing a song, and capture those kind of various waves, and eventually you put it back to the system. Now, again, this is very research oriented, right? There are a lot of research is happening, and I don't know if you follow. There is a company called Neuralink, which is, Elon Musk has invested, a couple of years back, and that they're also trying to build something where, using, without even touching the computer and using a thought process, you can operate a computer, right? You can actually connect by this kind of BCI device. You plant it on your head, and then with that, you think about thing, and your computer will operate, in sync with your thought process, right? Second interesting is signature dynamics. So this is an age-old concept. In banks, you go, you sign a check or anything, and they will match your signature, and it will tell you that, are you a right authorized person or not, right? Now there is nothing new into it. So why you are talking about it? Because with the help of AI, now we can do, and the smart devices, we can do something extra. So how about this? So there are two part of it. One is a structural correctness, and one is a behavioral correctness. What does that mean? Structural correctness means that is these two signatures looks similar, or same or not, right? Now, if you are, let's say, a person who forged signatures, um, so you can actually would be able to probably replicate my signature, but then it might take a longer time because you're not used to it, right? So for example, if I sign this is my signature, I might take probably hardly 5 seconds to do it, but for you to copy this, probably it might take 5 minutes. But if I give you 5 minutes, you can very easily create a perfect lookalike signature, right? So structural correctness is only valid as long as you are doing it in front of somebody. But if it is happening offline, imagine like, and I send a check to you and you sign it at home and you come back to me. I don't looking at this, I cannot verify that is this correct or not. So that's why the second layer can be added to that. It's called behavioral correctness. What does that mean? This means that when I'm writing the signature, am I writing this signature in the same pattern and the same speed or not? So basically, what we try to do is we look into velocities, like speed, how fast you're signing. Because if it's my signature, the amount of time I'll take now, probably tomorrow I'll sign, I'll take almost similar amount of time, right? The directions, am I signing left to right to left, or up and down? Which part of signature we're doing left to right or right to left? Which directions the sign is happening, signature is happening, right? Now there are a lot of smart devices as available where if you sign it with probably a stylus or something like that, it can actually measure the pressure points also. Maybe you're a person, when you're writing a signature, you put a lot of pressure, right? Or I'm a person who writing, I generally very softly hold the pen and probably sign, right? So we can actually look into those kind of behavioral aspects, because these are behaviors. I can copy your signature, but I won't be able to copy your behavior, right? So essentially what happens is, that can be that can be analyzed, and that can be visualized, and that can be actually verified as well through various kind of, obviously, the algorithms which we have today available, and the devices, obviously, right? So this is a pressure representation where, let's say, this looks, so the way it's been visualized is, this part of the signature, the pressure was more, but however, whenever there's a dotted line, the pressure was less. Whenever there's a thick line, there was more pressure has been given. So when I see two signatures and I see similar kind of pressure points, I understand that this is done by the same two person, right? So combine this with normal signature verification, and you become a better way of verifying signature. So this is the direction. Which part I write left to right, which part I like up and down, right to left, like that. So this is what we do, and obviously this is a very interesting paper which is published in Microsoft, which is a behavior-based gestures and signature authentication using gesture and signature. So with this, it can be done, and this could be a interesting, technology to actually protect your account, protect your data. Now, this is a very interesting movie. I don't know if you have seen. It's, I think, MI2, Mission Impossible 2. There was a scene where this guy was. So basically, this is like a vault is there, and then the person has to walk to the vault, and there will be this structure, this kind of arc like structure with a camera, and there was a gun also. So what they essentially do it, when you're walking, this will move along with you, and with the camera, it will actually evaluate your walking pattern, because your walking pattern is also unique, and this is called gait, gait. It's very famous in the sports world, where people actually use this to find the sports people's postures. If I'm a player, is my postures correct or not? Gait is called gait analysis. So this is using gait analysis. Your walking, its camera will, using computer vision, will analyze your walking pattern, and if it finds a mismatch, obviously in the movie there is a gun or something which will just shot, and either the person get killed, or probably somehow temporarily, obviously will you not be functioning, so that they can catch hold of the person. Now, mission impossible, right? But it is possible, quite possible today. It's no longer impossible. This is not a movie anymore. So this is called gait. That's what I'm saying. It's a walking pattern analysis or posture analysis. Now, we can do it with computer vision, and you can actually do a lot of analysis, and you can do it. However, the next step which is happening today is thanks to all the mobile devices, right? When you're keeping your phone in your pocket and you're walking, based on the phone's movement, like is it moving, like so each phone has sensors like gyroscope, accelerometer. Using that, you can actually measure the phone's movement, kind of different XYZ, all three directions, in 3D coordinate, their orientations, their speed also is an accelerometer. You can measure that. So with this kind of parameters in the sensors happen, available in the mobile, if your mobile is in your pocket and you're walking, we can actually do build a walking pattern analyzer. So whatever you see in the movie, the same thing can be done, but okay, you don't need a fancy camera or something which is covering you all 24/7, wherever you're going. Your mobile phone itself is actually giving that kind of data, and with this data we can create a pretty decent walking pattern analyzer, and which can detect that whenever the phone, no, let's say if it's my phone and it's trained with my data, and now whenever the phone is with me, it can tell that the phone right now, the owner of the phone is having the phone and walking. However, if the phone is goes to somebody else, it can easily identify that now the walking pattern changed, and obviously this doesn't look like a owner's pattern. Now there is a problem, or probably few of you would have already guessed, all these things. So one is obviously, what if I have injury, right? I maybe, or maybe I'm not feeling well today. I'm walking feeling tired, versus tomorrow I'm feeling very energetic and enthusiastic. I'm very happy, right? So this is actually a supervised learning where there, that's why this kind of algorithm people, when we kind of worked on or tried to build it, this needs a various variations of data. We need a lot of samples here. Now, normal work, fast work, running, sitting, walking upstairs, walking downstairs. So if you have like various pattern, various kind of thing, and then let's say if I get this six different observations across different days of the thing, like not even different days, different part of the day. Maybe morning one sample is being collected, afternoon one sample, evening one sample, and the same way, let's say I've collected this for a month of time. With that data, I have a fair understanding of different days of the week or a month, or probably different time of the day, what is the kind of your cycle or your behavior of walk, what kind of exhaustion you have and all this thing. So with this, and then obviously there are other complexity of orientation of the phone. Phone can get tilted, distorted, disordered. So there is a lot of normalization is required on this space, but it is doable. And with this, actually there is definitely a kind of model can be created using obviously deep learning, that can work with fairly accurate, and and actually identify the person based on their walking patterns. So this is called gait analysis or gait authentication. Now, the other interesting, and this is actually one of the most prevailing behavioral analytics in the industry, which is called keystroke dynamics, which is nothing but your typing pattern. Now, depending on the device you use, computer or mobile, your typing pattern is unique. This is called keystroke dynamics, and this can be broken down in different kind of parameters: typing speed. There's something called duration, how fast you type, how hard you press the key, how long you hold the key after you pressing a key. So like that, you put all this thing together, and then you actually create a model which actually can identify that what is your typing pattern. And essentially, this model can help you to identify whenever the rightful user is typing. Is it is the authorized user, owner, versus someone else is typing. So think of it now. Go back to the capture example I gave, like login, brute force attack, and all this, right? Imagine if I add this as an extra layer, I don't need capture because capture is broken, brute force is possible. So instead of that, if I do this, where I say that, what, one layer is your password, second layer is how you're typing your password. So which essentially means that what if you you will know my password, but you won't be able to log in, because the moment you try to enter my password, your behavior is completely different than my behavior. And essentially that becomes the second layer of authentication. So that's how there's an industry where these are all called passive authentication or invisible authentication. So how we actually can create some more models, more analytics, which is basically more is better. However, it is not causing too much friction or too much stress to the user. It has to be invisible, it has to be subtle, right? So that users don't get frustrated. So with that, there is these are the various kind of attacks, various kind of attacks happen, and to attack prevent them, we are coming up with this kind of different innovative analytics or innovative technology or layers of security which can protect. So this is continuously evolving. So it's like a cat and mouse game. So as I said, something is secure today. Maybe this dynamics is preventing today, but tomorrow someone bypasses it. Then we have to think of another algorithm which can actually take it to the next level. So like that is continuously evolving, and new and new kind of concepts are coming into the mainstream. So with this, I will stop. Okay, this slide about obviously a company, what we do. We do all this kind of offensive and defensive kind of work. But yeah, that's pretty much what I have to cover. And yeah, I think I will just stop here and let me switch on my camera. And yes, I think that's all from my side, and I'd be happy to answer if you have any questions. Thank you. I cannot hear you, Fatima. You're not audible. Let me check the chat section. Probably I don't know.
Hello.
Yes.
Okay. Yeah. That was a wonderful session, sir. We have some
Thank
questions
you.
here in the chat.
Okay.
The
Okay.
first question
I'm
is
just
from
yeah.
Dr. Subodh. For most of the machine
Mhm.
learning algorithms, the prerequisite is data. How secure our
Yes.
data is with such ML algorithms when these models are in production?
Yeah, that's a very good question. And so yeah, I think see the key is data at the end of the day, right? So that's why we say data is the new oil or data is the new currency, right? So we're not talking about, so just think of it today, right? Your identity is your mapped with everything, right? uh, I mean, your mobile becomes your identity, right? It's no longer your money, right? If I access your mobile, I can do and I know your pin, I can do UPI transaction and actually obviously transfer all the money from your account, right? So data is the key. So there are two parts to that, and that's another interesting concept. I'm working with a couple of obviously fellow researchers across the globe together. That one option is obviously so data and algorithm are two different things, right? So what we do is when you build a model gets trained on the data, and then data doesn't stay with the model, right? So if you talk about supervised learning, there's two parts. First part, you train the model with the data, and then data, you don't need the data anymore because the model is trained, and then you deploy that model in the production where now you start doing predictions, right? Where you then send the new set of data samples and say that okay, this is the data, and you predict, you actually tell is it good, bad, or whatever kind of predictions you want to do, right? So if you're talking about training data, that doesn't stay in the production. That's the first part. However, when you're talking about production, obviously there are new samples are coming where which needs to be predicted, right? So the train and test, if you're talking about, right? So the test API, and those data anyway has to visit the server. Now, there is no denial in that. But there is also a concept where what we're trying to do is, for example, especially in the authentication space, right? We don't want to send the behavioral data to the server, so we are trying to create a model which fits into the mobile itself, because data should be owned by the users. It's users data and it should belong to. So what if we, instead of sending data from user to the server, we are bringing the model from server to the user's devices only, because user's device at the moment I would say it's a mobile, the mobile belongs to me, so it's my responsibility to protect my mobile and the data inside the mobile. The moment data goes out of the mobile, that's no longer the user's responsibility, that goes to whoever is consuming the data. So there is other part is happening now. We're trying to create more lightweight model which can be deployed on mobile, work on the user's device, and do the predictions. That's the second part. Now the third part of that is actually, the question you've asked is multi-layers. I don't know if you realize is, when you're training also, right? In the first phase, when you're training, you need a lot of data, billions of data record. Where do you get it? For example, as I said, when I'm building this gate model, I need to get walking pattern of the users. Now let's say what no, what I did is I asked a lot of students. I went to colleges, asked students to volunteer to work for me and all this thing. Now, am I authorized to own this data? Probably not, right? It's your data, your working pattern. So there is a concept called federated learning or distributed learning. There's a new concept which is happening. The idea is there, let's say I will send you a model to you. You train it with your own data and you send back the model to me. You don't send the data to me, you send the trained model to me. So that way we are trying to say that your data should belong to you, and then all we need is a trained model, which it has nothing to do with the data. So rather, I will give you the model, I'll give you instruction how to train. You train the model at your server on your own premises, and then you give me back that model, which I'll be using it further. So that's how there are different way people are trying to protect their data. I hope that answers your question.
Yes, yes, absolutely. Thank you so much.
Thank you.
Okay, so the next, I don't know, it's not a question, but it's just an opinion from Bhakti. I have observed one thing, that gyroscopes in smartwatches
Yes.
more accurate results than those
Yes.
mobile phones. Step
Mhm.
count, for example.
Right. Yes. Yes. And there is a reason for that. One is, if you talk about smartwatches, that's in your hand, and when you're actually walking, your hand moves more. So the displacement, no, if you talk about the entire spectrum, I know I have the bigger thing. So if I have to differentiate between 0 and 1 versus 0 to 10, obviously it's easy to differentiate 0 and 10 versus 0 and 1, right? So the displacement is higher here in terms of smartwatches versus when you're keeping the phone in your pocket. Just a minor movement like this, it will be happening. Let's say if it's your leg and you're walking, only this much is movement is happening. Versus if it's a hand, it will move like this, right? So the displacement changes, so that gives me a better magnitude to actually count and more accurate count. That's one of the theory, but there are other obviously options coming in also.
Correct, correct. I had one question, sir. Is the
Yes.
one which you said password protected with your brain waves? So, what if like a person like dies or something? Then how does one access their account for critical
So
information?
that applies to the same, right? If I don't tell my password to you, and you won't be able to access my account, obviously, when I'm not there, right? So it's not about the thought, it's in general about. So the other thing you need to understand, how you define identity, right? So your identity in the digital world defined in three layers: what you know, what you have, and who you are, right? So what you know is like passwords. What is I know? So that is always in my memory, right? It could be password, and I'm saying instead of password, it is not replacing with the thought process. But as long as it's still, what I know, it's still in my memory, and unless I tell somebody, it will be nobody will be able to access it. Now, what you have is actually the second factor, which is your OTP comes to your mobile, or sometime I don't know if you know about, there's a multi-factor MFA toolkit comes, like in a lot of companies we get the key, we call it a private key, we connect to the laptop, and then only we can do it. And who you are is your biometrics. Who you are is your face, your voice, your fingerprint, your iris recognition. Those are who you are. That's your biometric, behavioral biometric, or physical biometric property. So there are three layers. So when we talk about pass thought or passwords, as long as you're talking about what you know category, everything applies to this person. As long as the person is there, that is valid. If the person is not there, that will not be valid.
So, Tamagna, I have another
Yeah,
question. Uh,
please.
so, most of our students are from the management background,
Mm-hmm. Mm-hmm.
where maybe they would need to know like how to maybe get started with the cybersecurity and the machine learning thing.
Got it. So if you are from obviously the management background, and so for okay, so the way I see it, first of all, you need to have passion for technology. Until you have passion, these are all we're talking about, a very little advanced technological concepts. I mean, when you talk about tech, obviously data science, machine learning, and all these things needs a lot of analytical work, right? So until you have passion, your inclination, you have inclination towards that kind of work, you will never be able to, you will not like this space, to be honest, right? It is something you need to have, that analytical level. You need to have that kind of feeling that you love to solve puzzles, right? You are the person who like to solve puzzles, right? So that's the first thing, right? You should have inclination towards this kind of thing. Second is, now obviously if you are from a tech background, and then you become it will be easier for you. Let's say if you probably have done engineering and probably some kind of kind of programming language, that will be definitely easier for you. If you are not, you still want to get into, obviously the security management itself is also a good domain. Information security management, ISMS, right? So I'm talking about the tech thing, right? And if you talk about security of a company, there are three layers: people, process, and technology. So managing that also overall, that there are different kind of practice you implement, you follow it up, you measure that on a regular basis. That is it being followed, is it being executed properly or not? So information security management, or ISMS, there are a lot of certifications inside there. You can do those certifications. Obviously, fundamental has to be security. You should still understand basics of security, what is encryption and stuff like that. And then you can go into this management kind of role where you actually say that I'm going to help the company to implement and manage the entire security practice.
Perfect.
Hi,
Thank
sir.
you.
I had another question.
Yes, please.
Yeah. So SHA 256 is kind of the most advanced, like one of the most advanced encryption techniques. And recently, even Google claimed that using quantum computers, they were able to solve some kind of calculations which would take thousands of years on a traditional computer. So, do you think we should be worried about quantum computers
You reach
being
so
able
that's
to
why there
break?
is a concept. There's a concept called quantum safe encryption. So so that is the new thing people are talking about. So if you know encryption, the fundamentals of encryption was computes were not good enough to crack that, right?
Right.
So majorly a lot of encryption is about brute forcing, and we say that if with the current or probably next 10 years the kind of compute we want to see, with that it might take 10,000 years for someone to crack this. Like that's how the fundamental of a lot of encryption algorithms were, and when it got invented. But thanks to quantum computing and all this thing, those things is broken now. There is surplus of, there is an abundance of computes, there's abundance of storage, there's abundance of bandwidth. Network is no longer a problem. So everything becomes so much available. The infrastructure is no longer was a parameter for you to decide, is this a safe encryption or not? You're able to follow me, right? So that's why people are now talking about new kind of encryptions, and quantum safe encryption is obviously, that's a subject where people are studying and figuring out what is the next best thing we can do, so that that will no longer depend on this kind of infrastructure based parameters, and so that we have a better way of solving the encryption. Now, what specific of that I'm not an expert, unfortunately, but that's obviously an area I would love to learn, and I just spare time. That's something in my bucket list. Next big thing is I want to do is learn more about quantum safe computing. Encryption.
Yeah, I think that answers it for me.
Thank you.
If there aren't any more questions, we can proceed with the vote of thanks.
Okay. So before we log off, I'd like to thank our speaker, Mr. Tabagna Basu, for accepting our invitation and for being here with us today. In this age of social media and billions of digital devices, the danger of cyber attacks looms at large for almost anyone who uses the internet. Hence, it becomes really important to understand the risks of going online and securing ourselves using cybersecurity. Adding to this is the use of advanced machine learning techniques that can either strengthen existing methods of online security or be used to attack networks and crack passwords. This talk of yours shed light on the topic, and I'm sure everyone took note of all that was explained today. I'd like to thank our director, Professor Dr. Uday Salunke, for his support and guidance throughout the event. I'd like to thank the IIC team members, Professor Dr. Kaustubh Dargalkar, Dr. Vaishali Patil, Dr. Garima Sharma, Mr. Sagar Deshmukh, Mr. Amaya Vaingankar, Ms. Shruti Mangaonkar, and others for their efforts. I'd also like to thank our edX mentors, Dr. Subodh, Dr. Sonali, Dr. Sonal, and Dr. Rohan for their guidance, and the team members for smoothly conducting the session. Lastly, I'd like to thank the participants who attended this session, and I hope this event was helpful and you learned a new skill today that can be pursued in the future. With this, we formally conclude the session. Thank you everyone once again for being here. Take care and see you all next time.
Thank you.
Thank you so much.
Thank you.